Hi, my name is Ying, and in our team, I was mainly in charge of the Challenge 1 and Challenge 2, which are the low brightness event and the chasing car event. So my role focused on detecting these events from the game cameras and to decide the correct response and integrate that response into the car's automatic control logic. So for the gate commit that I choose is this one, cope with Challenge 1 and Challenge 2. So I want to explain about the implementation of the chasing car event. So the outcome of the implementation is the program will continuously read the back camera and detect the chasing car using a color-based OpenCV approach. And it checks whether it is in the same lane as our car, then it triggers an avoidance maneuver. So I also added an overlay visualization so that we can see the detection box and confirm whether the system thinks that the chasing car is blocking our path. The reason why I selected this algorithm is because it is lightweight, fast, and it is still suitable for RTOS system. So I use OpenCV color masking instead of a heavier approach like YOLO modeling or template matching, which I actually tried implementing it before. But the YOLO required a large dataset collection in training, and the template matching was not stable enough and it was expensive for our RTOS loop. So for the low brightness event, I use a lightweight method instead of machine learning also. The system checks the overall scene brightness and the ratio of bright pixels. If the scene becomes uniformly dark, it recognizes that as the low light challenge. Then it sends the acceleration input as negative 1.0 to recover the light. So now I'll briefly walk through the main part of the code for coping with these two challenges. So this is the main function for detecting the low brightness. So first thing that I do is I convert the frame into a grayscale. And then I measure the average of the brightness and the bright pixel ratio. And I also compare the left and right half of the screen. So I only trigger when the whole scene becomes dark, not when only half of the screen is black, when we get the punishment from yellow token. So the main function for chasing car would be this function. So first thing first, I crop the ROI frame for performance, and then I convert it into HSV and VGR mask. After masking and morphology cleanup, I find contours and score the best candidate based on the area, aspect ratio, and the field ratio. So this part here, it determines whether the chasing car is near our player or whether it is in the same lane as the player. This is important because we don't want to avoid the car when the player is already like not in the same lane or the chasing car is not anywhere near the player. This is the direct actuation for challenge 1. If the low light is active, then the acceleration is forced to negative 1.0, which is what the game requires for us to solve the brightness problem. This right here is the planning part of the actuation for challenge 2. When the chasing car is visible, the system computes an opposite steering action and creates a chase avoid target. And you can see here when the target choice is our row path choice, which in this case is our chase avoid target. When this path is chosen, the block converts it into actual steering commands. For example, 1 for right, negative 1.0 for left, and 0.0 for straight. We can see the code of the actuation right here.